Hello everyone. In this question, it is given that if tan alpha and tan beta are the roots of the equation x square minus bx plus c equal to 0, then show that sin square of alpha plus beta equal to b square divided by b square plus 1 minus c whole square. Okay. So the given quadratic equation is x square minus bx plus c equal to 0. Okay. So if we compare it with this equation, ax square plus capital Bx plus capital C equal to 0. Okay, if we compare it, we get a equal to 1, capital B equal to your minus B, then capital C equal to your small c, right? Okay, the roots are tan alpha and tan beta. So we can use the sum of roots. The sum of roots tan alpha plus tan beta will be minus of capital B by capital A, which in this case is negative of negative B upon 1, which gives us B. And then we have the product of roots, which is given by capital C upon capital A, which in this case will be C upon 1, which gives us C. Okay, so we have these two values, right? Tan alpha plus tan beta and the product tan alpha tan beta. Okay, so we have to find what is sin square of alpha plus beta, but we have the values of tan alpha plus tan beta and the product tan alpha times tan beta. Okay, so let's first try what is tan of alpha plus beta. Tan of alpha plus beta will be your tan alpha plus tan beta upon 1 minus tan alpha times tan beta, right? So this is your tan alpha plus tan beta is B, right? And 1 minus tan alpha tan beta will be 1 minus C. So this tan alpha, this is B, this is 1 minus C. Okay, so let's square it and see what we get. Tan square of alpha plus beta will be this B by 1 minus C whole squared, which is B squared by 1 minus C whole squared. Okay, so this we have to show sin square. Okay, sin square alpha plus beta is B square by B square plus 1 minus C whole square. We see tan square alpha plus beta, it has got some factors like B square in the numerator. In the denominator we have 1 minus C whole square. So it's starting to look like we are getting closer. So we have tan square, so let's find out what is sec square alpha plus beta. Sec square alpha plus beta will be 1 plus tan square alpha plus beta. Okay, so this is 1 plus this will we have derived above 1 minus c whole square in the denominator, which will give, after taking the LCM, the numerator will get 1 minus c whole square plus b square upon 1 minus c whole square. Okay, now we have sec square, we want sin square. Okay, so let's, from sec square, let's find out what is cos square. Now cos square theta is 1 by sin square theta, it is the reciprocal, so same here theta is alpha plus beta. Okay, so cos square alpha plus beta will be 1 by sec square of alpha plus beta, right? So this will be 1 upon this entire thing that we have deduced in the previous step. So this 1 minus c whole square will go in the numerator, and in the denominator we will have b square plus 1 minus c whole square. Okay, so now we have got cos square alpha plus beta. So it will be very easy to finally find out what is sin square alpha plus beta, because sin square theta is 1 minus cos square theta. So in the same way, sin square alpha plus beta will be 1 minus cos square alpha plus beta. So it looks like we have finally finished the sum. Almost get gotten the structure. After taking the LCM, this is your first term after taking the LCM. Then we have a minus here, minus of 1 minus c whole square upon b square plus 1 minus c whole square. Okay, so finally we get these two terms get cancelled out. We are left with b square in the numerator upon b square plus 1 minus c whole square, which is what the question wanted us to show. So yes, we have shown it finally. Here we've done it, showed. Now is there any shortcut? We have found out what is tan, and we have squared it. We found out when tan square. From tan square we went to sec square. From sec square we went to cos square, then sin square. So let's try if there is a shortcut method to the above question or solution. Okay. We have sin square alpha plus beta equal to, we can write it as tan square alpha plus beta by sec square alpha plus beta. This is because sin theta can be written as tan theta upon sec theta, because tan theta is your sin theta upon cos theta, right? And sec theta is 1 upon cos theta. So these two will get cancelled out and we are left out with only sin theta, right? So this is what I have used here. I just squared it. So sin squared theta becomes this sin squared theta will become this whole square, which is what I have used here. Okay, so now let's find out what is sin square alpha plus beta directly. Just tan square alpha plus beta, and we can write sec square as directly 1 plus tan square theta. Okay, so what is tan square alpha plus beta? Is here, right? Tan square alpha plus beta is b square upon 1 minus c whole square, right? So we will use that here. B square by 1 minus c whole square plus 1 plus b square by 1 minus c whole square. Okay, so if we take the LCM, in the numerator we will find we have this entirely divided by 1 minus c whole square. So this and this will get cancelled out and we are left with b square by b square plus 1 minus c. Oh, sorry. One minus c whole square. So we have showed it again, and we required much less steps compared to the previous one. Here we have directly computed the value of sin square from tan square directly. We needed fewer steps. So this is it. Thank you.